Hi dears, welcome to my class. In this lesson, acid, bases and salt, we learned about the basicity of acids, ionization reactions, etc. And hope you have gone through all those concepts. And also we saw how the global phenomenon occurs due to the deposition of non-metallic oxides in the atmosphere. And we discussed about its remedial measures and suggestions. So let's learn more about alkalis and its reactions in this video. I know that you all know about the common characteristics of alkalis. But even though, let's recall about it once again. Alkalis usually possess an alkaline taste. It is soapy to touch and it turns red litmus to blue. Let's do some activities to know more about alkali. A neatly rubbed and cleaned magnesium ribbon is burned. You can see that a white powder is obtained after the burning of magnesium. Do you know what would be this white powder? This white powder is called magnesium oxide. Now take the product in a test tube and add 2 or 3 drops of water. Dissolve this solution properly and find its nature using the litmus paper. What change do you observe here? Could you find the nature of this solution? Is it acidic or basic? Yes, the red litmus turns blue means the magnesium oxide is basic in nature, right? So shall we do another activity? For this activity, we need calcium oxide and water. Let's take some calcium oxide in a beaker. This calcium oxide is commonly known as quicklime. Now add some water into the beaker and dissolve the solution. As you can see that the calcium oxide is partially soluble in water and it settles down. So shake the solution a little bit to dissolve it quickly. Now dip a red litmus paper into the solution. Children, what do you infer about the nature of this substance? Yes, without any doubt we can say that the solution is basic in nature. Am I right? So the calcium oxide reacts with water and forms calcium hydroxide. Now, if you touch the bottom of the beaker, you can feel the hotness as it is an exothermic reaction. Now, can you see the calcium oxide that deposited on the bottom of this beaker? Alright, observe these equations. What do you infer about the nature of the product obtained from this litmus test? Are magnesium oxide and calcium oxide metallic oxides or non-metallic oxides? We found that the litmus paper turns to blue. So, generally the metallic oxides exhibit the characteristics of bases. But the bases that dissolve in water are called alkalis. So remember, bases and alkalis are extremely two different words, but they are literally used as same. Now from the oxides given below, can you find out the basic oxides? How will you find out? You have to check whether the given compound is a metallic oxide or non-metallic oxide. Hope you got the answer. The potassium oxide, magnesium oxide and calcium oxide are examples of metallic oxides. So they act as a basic oxide. Now let's learn about some of the chemical formulae of alkalis. Sodium hydroxide, otherwise known as caustic soda. Chemical formula NaOH. Calcium hydroxide, known as milk of lime. Chemical formula ACaOH twice. Ammonium hydroxide, otherwise called liquor ammonia. Its chemical formula NH4OH. Potassium hydroxide, known as caustic potash. Its chemical formula KOH. Magnesium hydroxide, known as milk of magnesia, and its chemical formula is MgOH twice. Children, You must know about all the chemical formulas of acids and alkalis that we learned in this lesson. Let's find out the common component present in the alkalis. For that, here are some of the ionization equations of alkalis. Observe these equations and can you find out which is the common ion released when alkalis dissolve in water? Absolutely, you can find that hydroxide ions, right? OH minus ions are called hydroxide ions. So on the basis of the hydroxide ions released in the water, we can define alkalis. So what are alkalis? Alkalis are substances which can increase the concentration of hydroxide ions in an aqueous solution. So what are alkalis? Substance which can increase the concentration of hydroxide ions in an aqueous solution. Now you learned about the definition of acids and alkalis in terms of H plus ions and OH minus ions, right? But there is a scientific theory regarding acids and bases put forward by the Swedish scientist Svante Arrhenius. According to his theory, acids are substances which liberate H plus ions in aqueous solution, and bases are substances which liberate OH minus ions in aqueous solution. Students, in general, we can say substances which liberate H plus ions are acids and those which liberate OH minus ions are called bases. So students, let's conclude today's class. In this video, we learned about alkalis, basic oxides and their characteristics, chemical names and formulae of some familiar alkalis, ionization equations of some alkalis, and Arrhenius theory. Alright children, let's meet you in the next class with another new topic. Thank you for watching this video.